Morning, everyone. It's good to be here with everybody. I think this is Samtec's 5th or 6th year in a row of sponsoring ETT. It might be a bit longer than that. I'm not quite sure. While they bring up the presentation, just want to thank the leadership team at VITA for allowing Samtec to be a part of this. We always look forward to ETT. We think it's a great event, not only to give a little bit of information about who Samtec is, but more importantly, to interact with so many of our partners, our customers, and our media partners. So thanks for getting the presentation up. Let's make sure this works. It does. As a matter of introduction, my name is Matt Burns, Global Director of Tech Marketing at Samtec. I've been with Samtec for about 8+ years now, after a career as, I used to be a design engineer. It's been a long time. And it's been about 11 years in distribution before getting into the component side of the business. One of the things that we're always excited to talk about is where the SoM market is going, or system on modules. So we're going to talk about some of the trends that we see from Samtec's perspective. This is not exhaustive of the entire system on module or computer on module market because we don't have insight into everything, but we will talk about some of the things at least that we see from an industry standpoint. Before we get into system on modules, I thought I'd give just a brief overview of who Samtec is. Obviously, we're a high-performance interconnect manufacturer. We've been in business for roughly 48 years, founded in 1976. We're headquartered in New Albany, Indiana, which is right outside of Louisville, Kentucky, right across the river from Louisville, Kentucky. We are a global company in terms of manufacturing, all three major regions of the world. We have business 125 countries, either directly or through our global distribution channels, and we employ about 7,500 employees. From a business perspective, our mantra is really sudden service. It's really working with customers, understanding what their technical needs are. Several of our customers are in the room, so I better be careful what I say. Thank you for your business, by the way. But our focus is really trying to understand what our customers need and then come up with a solution that provides that. And as a result of that focus on customer service, whether that's providing samples, whether that's getting parts to you in 24 hours or 2-day transit anywhere in the globe, it really enables Samtec to diversify the industries we play in. So there's about 7 key industries that we focus in on. Consumers, number 8, as shown there. And between that focus on customers, making sure that we're a technology leader as well, that's really enabled the company to grow faster than the industry throughout the history, over the last 10+ years, and in general throughout the life of the company. One question we always get: Samtec, privately or public? We're privately held, so we're owned by the son of the founder of the company. This next slide we use in a lot of our corporate presentations, but I think it ties in very nicely with what we see in the system on module ecosystem. Listening to some of the presentations that we've had so far, there's definitely technology trends that are affecting the industry. 2 years ago, if any of you would have asked the question, what is ChatGPT, probably wouldn't have heard of it. Or we wouldn't have paid attention to it, to the fact that or to the level that we have over the last 18 months or so. And then the explosion of AI capabilities has really affected every corner, not only of the industries that we play in, but every facet of life. We've been monitoring, Samtec's been monitoring that for the last 5-6 years. We're working with the AI chipset vendors, which in turn is becoming SoM vendors. And we're bullish on where AI is going, as well as a number of folks there as well. In addition, New Wave and some of the other folks talked about wireless connectivity. We see that not only with 5G, 6G coming down the pike, we also see that through a lot of the network connectivity that we see through that's provided through satellite. So we're real excited about that. Automotive 2.0 kind of speaks for itself, and so does high performance computing. When we talk about these trends, these technology trends, this technical renaissance that Samtec sees, from our perspective as a component provider, it's not just about providing a interconnect, it's about providing a solution. And when we say solution, we're typically talking silicon to silicon. So if I need to route an electron from point A to point B optically, a photon, or wirelessly, through the RF spectrum. How do we help our customers? How do we help our partners to get data from point A to point B? The reason that's of interest is data rates are growing exponentially faster. Whatever your opinion is on Moore's law, that has had a direct affiliation with how fast speeds are at the channel. And if you look at the history of data rates as they increased, it was, especially back in the 90s, I think of the old megahertz wars back between the AMD and Intel at the time. The semiconductors were really driving the performance within the embedded space, within the data center, et cetera, et cetera. And the interconnect companies were struggling to keep up. But what we've noticed from our perspective anyway is over the last 10 years or so, last 10 to 15 years, the interconnect companies have really had to push innovation to make sure that we come up with high performance solutions that in essence are available before the silicon. Why is that? Well, the OEM vendors, whether it's data center, mil-aero, embedded, whatever the case may be, they have to construct their entire channel. And it's not a design in the real world system, it's really designed in a digital twins in the virtual world. So by having our models, by having our latest solutions available before the semiconductors in general, that's really enabled us to push the envelope in terms of performance and push the envelope in terms of the solutions that we offer. When we talk about solutions that Samtec offers, we really, we mentioned silicon to silicon. And it's anything in the COP world, front panel to back plane. Thank you to New Wave and to TechWay. They talked about our Firefly. I feel like we should pay you guys for that advertisement. We appreciate that. Anyone else wants to, that's okay too. We appreciate it as well. Sorry, that's my attempt at humor. But when you look at our product portfolio, just going front panel to back plane, extreme performance I/O, ultra rugged power, flyover technology, which in essence is, as data rates get faster, the trace lengths that you have on PCB lengths are limited. So you can put retimers and drivers down there, but our thought process is let's pull the data out of the PCB and put it into a copper twin-X cable and fly it over longer distances. That obviously also works in the optical arena as well, but say sub-meter, maybe sub few meters, depending upon the data rates, we can handle that in a copper way as well. What we're going to talk about here in just a moment are high-speed, high-density arrays, obviously the mezzanine connectors that define SoMs, and you can see the rest of the portfolio that we offer. So enough of our Samtec commercial. What do we see within the SoM and COM market space? And for those of you, this is probably the wrong slide to have in this room, but just in case. For those of you that are not aware of what system on modules or computer on modules are, it's really about, it's a conversation of make versus build. Do I actually want to design my compute system from scratch, or do I want to take advantage of something that more than likely is going to be standardized, tested, available for multiple providers, second source, which gets rid of supply chains, and use something off the shelf like a system on module or on a compute on module concept. And when you look at these SoMs, when you look at the COMs, it already has the digital compute engine, whether that's a CPU, FPGA. We're starting to see RF SoC solutions like it's been alluded to. But it also comes with the memory, it comes with the I/O, it comes with all the concept or all the functionality that you need within a single small form factor. We'll talk about form factors here in just a moment, because they are continuously evolving. I talked earlier, or just briefly introduced some of the concepts or some of the benefits of using system on modules, computer on modules, faster time to market, reduced development costs. We've seen, and again, I've looked at this in my previous life working at distribution at Avnet. I've looked at this working here at Samtec. In general, when you do make versus buy, you're saving 12 to 18 months of development time. So some may consider, well, I can save money if I design something discreetly, but how much NRE are you putting into that? I was talking to a vendor recently, in December, created a new platform based on PCI Express. It was a 12-month development time, $500,000 investment. Or he could have bought modules off the shelf. So it really depends. Every customer, every OEM has to kind of make that decision. But increasingly, SoMs and COMs are becoming de facto project starts within the embedded space. The graph that we show here, I borrowed from PicMig. Thanks, Jess. Thanks to the PicMig team. This illustrates not only how comms and SoMs are keeping up with performance within the ecosystem from a semiconductor standpoint, but also from an interconnect standpoint. And when we start to dig deeper into this, we'll talk about the differences, at least from Samtec's perspective, CommE versus CommHPC, and why some of these next generation SoM form factors are needed to keep up with the performance that's available not only on the interconnects, but also on the semiconductors as well. So one of the first things we want to look at is the solutions that are available from SGET. Again, this, just as a preliminary, this presentation is purely from Samtec's perspective. This is not designed to be industry-wide, an overall view. So these are the solutions that we run into within our customer base. Q7, I should have had SMARC after Q7. I made a mistake when making that slide. Q7's been on the market space for a good 15 years or more. It's designed specifically to go into embedded computing solutions. Historically, it's been the home for not only lower end or entry-level x86 architectures, but also more recently, a lot of innovations being done using ARM processors from TI and XP and the like. There's multiple sizes of Q7. It's a workhorse within the industry. And from an OEM's perspective, and this is bad for Samtec and our interconnect frenemies here in the room, there's no connector. Or you're using a DRAM, a cost-effective DRAM style connector. Very rugged, very well used, very popular, and we continue to see innovation in that space, not only within SGET, but also within the types of compute engines that are available on Q7. SMARC was introduced a few years later after Q7. One of the advantages that SMARC has over Q7 is the fact that it's smaller. So the trend that we see within SoMs and comms is typically what we see in the connector world. Higher density, higher performance, smaller form factor. So SMARC was introduced probably about 10 years ago, plus or minus. And it takes all the benefits of Q7, but puts it into a smaller form factor, especially in a credit card sized module. More recently, one of the latest innovations from SGET is the Open Standard Module, or OSM. Rich, maybe they have to pay you for using the OSM. I don't know if they're getting royalties from that, but hopefully you are. Good. So anyway, so benefits of the Open Standard Module. Again, this is bad for Samtec. There's no connector. For the OEMs, that's great. But again, the advantage of OSM, it's using BGA style attachment to the carrier card. There's three or four different form factors, and it's smaller. It's dense. It's denser, and it's higher performance. Again, Q7, SMARC, OSM. You can see the progression within the SGET ecosystem of things. And when it comes to SoMs and comms, again, our observations from Samtec, for a number of embedded applications, smaller, faster, lower cost is definitely the challenge. But the question comes up is, okay, SGET solutions or these are obviously open source, following industry standards, and we see other solutions from other providers that are same credit card size solutions that are great for ARM solution or ARM interconnect or for introductory x86. But for systems that need higher performance capabilities, especially when we're talking about AI and intelligent connectivity through wireless, et cetera, can these solutions really provide the performance, the power that they need to handle all that compute? And I would suggest, and the folks at PICMIC would suggest, no. And the reason is that you look at the proliferation of CommExpress. It's been on the industry for about 15 years. There's a lot of high-end embedded computing that CommExpress can handle. For many, it's the most popular embedded form factor available on the market. You can see from the illustration that there's multiple form factors, good I/O connectivity. Several key features of CommExpress that make it very popular even today: 8 different types, 4 different sizes, 3 major revisions. One of the challenges that CommExpress is also, the CommExpress technical working group within PICMIG has also worked to extend the life cycle of CommE, is the fact that the recent CommExpress 3.1 specification came out. Now you may consider, why is that important? First, it adds USB 4 to the Type 6 designs, which again is taking advantage of some of the latest high-speed connectivity within the embedded arena. It adds the sidebands for 10 gigabit signaling on the Type 7 modules. And what I thought was really important, and probably the biggest selling feature for the COM-E 3.1 specification, is the fact that you added PCI 4 connectivity to the legacy COM-E connectors. Why? Well, if you look at a lot of the embedded processors, x86, ARM, even some of the other embedded portfolios that are out there, they started implementing PCI 4 natively on the chipsets. So having a roadblock at PCI 3 limited the opportunities to use COM Express in so many applications. So by adding that additional high-speed functionality, changing the design, optimizing the breakout region within the interconnect, the COM-E ecosystem was able to extend the capabilities of COM-E. Now, with that being said, PCI 4 is great. That gets you 16 gigatransfers per second on the channel rate, and that can handle a lot of high-speed I/O and a lot of applications. However, as has been alluded to today, PCI SIG continues to innovate. PCI SIG is the industry standards body that owns PCI Express, and every 2 to 3 years, they double the performance rate. So PCI 6, 64 gigatransfers per second, was released in 2022. PCI SIG is working on PCI 7, which will be released and should be released next year. That gets you up to 128 gigatransfers per second per channel. Now, as the embedded ecosystem, we're not quite there yet. From our perspective, and this is just something I continue to see, I tend to think of data center as sort of leading edge in terms of performance at the channel rate, and I tend to think of the embedded ecosystem as maybe a generation or two behind. And not necessarily that that's a bad thing. You don't need PCI 7 when trying to develop, an embedded computer that goes on the factory floor. However, you need higher speeds. So that's really where COM-HPC went from. When Pickling started looking at the reality of COM-E, this is probably about 4 or 5 years ago. Why was there a new standard? COM Express was limited. I should update this slide. It's no longer PCI 3. When COM-HPC came out, it was PCI 3. It's PCI 4. And you only had a max of 10 gigabit Ethernet standpoint. COM-HPC overcame those limitations. It was a connector change. And Samtec is, the leading provider there, so we're real excited to have the COM-HPC connector, which we'll talk about. Some of the new capabilities that COM-HPC have: support for PCI 5, we're working on PCI 6, increase the PCI Express lanes from up to 64, 65, because you actually have a control line, 25 gigabit Ethernet, 100 gigabit Ethernet, and other interfaces as well. When COM-HPC came out a few years ago, one of the questions was COM-HPC designed to replace COM-E? And the answer is definitely not. It's all about extending the capability using a standard computer on module form factor and being able to scale from one module to another while providing for a path forward for the higher speeds. COM-E is obviously going to be around for another 10 years, if not longer. But COM-HPC overcomes the bottlenecks in terms of performance that COM-E has. The other advantage that COM-HPC offers is the fact that with all of the trends that we see in the industry, AI, these high-speed wireless connectivities, enabling the intelligent edge requires higher functionality from a compute engine standpoint. And at least in my opinion, I think that's where COM-HPC is really going to add value over some of the other SoM form factors that we've mentioned. So just briefly, some of this may be repetitive for you, but if you haven't seen COM-HPC, it defines 3 COM modules. There's the client, which is sizes A, B, and C. I took out the mechanical sizes of the COM modules, but that's available online. The client's high performance COM, sizes A to C. Again, they scale not only from a connector standpoint, but from an electromechanical standpoint. With a client, you can get up to 48 lanes of PCI 5, which should port to PCI 6 pretty easily. And there's a lot of multimedia applications available in terms of the rich video and audio. It takes advantage of the two 400-pin connectors. More Ethernet, more USB, and obviously it's a PICNIC standard. The server expands upon that. The same form factor, ABC, that you use for the client, those same form factors can expand using the server, which is D and E. So, if anyone's looking into ahead 15 to 20 years in the future, if you design the same carrier card with all the mechanical hooks, you can keep the same design and just scale with modules as necessary. So some of the key features of the COM HPC server, 65 lanes actually of PCI Gen 5, platform management via IPMI, up to 1 terabyte of DRAM, that's a lot of memory for an embedded system, 8 by 25 gigabit Ethernectivity, the 2 800-pin connectors, and obviously it's a PICMIG standard. Now, some of the feedback that PICMIG got from the industry is like, this is great. We love the high speed. We love all the hooks, all the bells and whistles. We love all the high performance. We love all the capabilities. But I still need to fit something in a slot that's the size of a credit card. What can you do? And the latest PICMIG COM HPC specification 1.2 was really designed to answer that question. So the latest spec, the latest COM HPC spec 1.2 introduced the COM HPC Mini. So it's about 95 by 60 millimeter. It's half the size of an A module as defined by COM HPC. And you'll see that it's very similar to a COM Express Mini module. But it has all the advantages of COM HPC. So instead of using the COM E connector, it uses only one 400-pin COM HPC connector. So you get the PCI 5, you get the 100 gigabit Ethernet, you get USB 4.0, et cetera, et cetera. It does have a refined pinout from the COM HPC down to the COM Mini, but it opens up a treasure trove of applications using the latest performance COM available from PICMIG in a more traditional credit card sized form factor. So those of us sponsor companies that worked on the ecosystem, we're really excited about the opportunity that presents, and we're anxious to see how the market accepts it over the next several years. I do sell connectors, so I do have one slide on interconnect. Jerry, forgive me, I do have to pay the bill somehow. So our COM HPC interconnect solutions, high performance open pin field array. Open pin field array basically means any one interconnect within the connector can act as power, ground, high-speed differential, high-speed single-ended. That flexibility of the interconnect was ideal for COM HPC as we tried to make the pinout with all of these high-speed IOs while also putting the appropriate grounding scheme in to allow for the signal integrity needed for these high-speed protocols. Other key features, 400-pin connector and a 4x100 row, 0.635 millimeter pitch, so it's very dense. There's 2 stack heights, 5 millimeter, 10 millimeter. It's very thin. It's about 70 millimeters long, 9 millimeters wide, and then 5 or 10 millimeters tall, depending upon the application that you support. And then it can handle up to 360 watts over both connectors within the COM HPC ecosystem. So that was our brief overview of what we see within the SOM and COM market. If there's any questions about Samtec or about SOMs and COMs or anything, we'll be glad to take those.